What's going on, everybody? It's Nick. Now, I've made around $1 million over the course of the last 12 months with Make.com. I've both built automations for other people and then sold them, and I've also used them for my own businesses to help generate revenue, drive sales, and that sort of deal. And what I want to do over the course of the next hour, maybe hour and a half, depending on how feisty we are, is go through literally every single Make.com function that I've picked up on my time on this platform. Not every Make.com function is useful, but knowing every Make.com function will go a long way towards making you dangerous on the platform. And that's what I want to do. I want to show you practical examples of how every single function works. So strap in and let's get into it. Okay, so what I have here is I have our scenario builder open. I've named this scenario every Make.com function, how each one works and which one you should use. And in order to make this as simple as humanly possible, I'm just going to go and select the tools set variable value. I'm going to unlink this, drag this over here, and then this is just going to be our playground. And it's where we're going to manipulate these Make.com functions and so on and so forth. I'm also going to zoom in a little bit just so everybody can see my screen. Make.com could be a little bit tough to see, especially with all the sunlight out there. Yeah, and we'll sort of walk you through things end to end. Now, if you click on a field and you open it up, on the right-hand side, a little modal is going to pop up. The first thing you're going to see is a star, and that just refers to, this is like the variable picker that lets you see variables from modules before you. But what I'm going to do in this video is I'm going to cover everything except for that. So I'll cover the settings, I'll cover the math functions, the text and binary functions, the date and time functions, functions for working with arrays, and I'll even cover some custom and system variables. Now, I'll be honest, the general functions and the math functions, while they're useful, they're probably not as useful as most of the other ones. So just being cognizant of the fact that most people on YouTube will watch, like there's like a linear relationship between the length of the video and how many people are remaining at the end of it. That's obviously not going to be you. But just to be cognizant of that, I will start with the most commonly used functions, the text and binary ones, the ones that I personally think drive me the most revenue and that simplify my life the most. And then I'm actually going to work backwards. So we'll do text and binary first, then we'll do date and time, then we'll do math, and then we'll do general, and then finally we'll do custom and system variables. So without further ado, let's get into easily the most powerful of the whole function suite, the text and binary functions. So first things first is you have a bunch of different vaguely rectangular things here, and I'll start with the simplest. Excuse me, the simplest is length. Now length, I think, is pretty self-explanatory. Essentially, Make.com has a bunch of different data types. One of the data types is string, another data type is like number or int, another data type is array, another data type is object or collection. Length basically just tells you the length of a string or of an array. And so if I type a very long string in here, which is just a collection of characters, well, I should be very careful with my words when I say the word collection, because that's also a Make.com term. It's technically an array of characters, and then we run it. You'll see the output is bundle1 playground 15. So the length of a very long string is equal to 15. This is an extremely useful function. I use it all the time, specifically because it helps me perform like string operations. If I'm attempting to get, I don't know, like a URL or something like that, I can check to see the length of that URL before proceeding. Or if I'm running something in OpenAI and I'm having, my system generate a certain, let's say I'm generating a proposal or something like that. I'm having it generate a certain string or snippet of text. The way that a lot of APIs and a lot of like proposal platforms and a lot of CRMs work is, depending on the length of the text, other elements in the page get moved around. And I'm all about maximizing the customer experience. I want things to look really nicely. So, sometimes I may count the length of a generation, and then if the length isn't between a certain character limit and another character limit, I just do it again, and I sort of redo the flow. This helps me get like that nice looking sort of like paragraph-wise layout on a page. It's super, super useful. And I also use this in conjunction with a bunch of other functions, which I'll show you right now. The next function is called lower. Lower is hopefully pretty self-explanatory again. Basically, you can feed it any string, and then by passing it into this lower function, if we run this module, it will convert that into the lowercase version of that. So we fed in all uppercase hello, and then we got out all lowercase hello. And this is pretty useful when you are dealing with certain APIs that have naming conventions where everything needs to be lowercase. You can also do this to format URLs. Like part of my work when I was developing like automated content sites was I'd have, some URL or whatever. And then at the end of the URL, I'd have, the name of a blog post. And a lot of the time, to make it as simple as possible, I would just take the title of the blog post and then I would feed it into the URL. But obviously, the title is usually capital case, right? Or start case or whatever it's called. So in order to prevent that from I guess just like ruining the aesthetics, I would always just pass that in a lowercase, and then get something like this instead. And I'll show you how to encode URLs in a second as well. That's quite useful. The next is capitalize. This is pretty self-explanatory. Internet. Actually, let's say you are sending an email, and sometimes the data in your CRM has like a lowercase proper noun. So maybe it's Peter lowercase. If you pass it through the capitalize function, then you'll have your uppercase P, Peter. Stuff like this is extremely simple, and I use it all the time. Anytime I'm dealing with some type of like formal communication, or I'm attempting to like maximize the quality of the perceived customer experience by being very correct and that sort of thing. So in email communications, anytime I'm drawing from an API or whatever, I will always just run it through capitalize or start case. This just helps me get that 1 in 100 chance when the data isn't formatted properly or somebody on the team doesn't put it in right. This fixes it. So always good to implement stuff like that. Start case is another example of the capitalize function. It's just instead of capitalizing the first letter of a whole string, it'll capitalize the first letter of every word. So let's say I have a guy and his name is Peter Smith, right? If I am feeding this into some proposal or something like that, I will use start case and then feed in the first and the last name. And this will just sort of like cover my own ass so that I never run into an issue where you just have like some poorly formatted introduction or whatnot. Okay, now we get into some functions that a lot of people aren't very familiar with, and I'll touch on them regardless, but I want you to know that these are very, very rarely used. ASCII is a good example. So, if I am working with people in, I don't know, French or other languages where accents are more common, a lot of the time, unfortunately, certain APIs do not allow you to send characters that have accents or non-standard characters that you wouldn't necessarily find on like a QWERTY keyboard. And so ASCII is just a way to fix that. And essentially, if I were to feed in Clementine, I don't actually know how to say that en français, but it has that accent aigu, that little up accent on the E. And then if I were to feed it into this function, ASCII, and then run it, essentially what's happening is it's just pulling out any character that's not standard or not part of the ASCII ASCII set. Now, obviously, I think in most cases, you don't actually want to do this. You just want to like remove the accent. And so functionally speaking, like in practice, what you normally do is you'll feed an ASCII with a thing and then a semicolon and then true. And then what this will do is this will actually keep the letter. It's just going to remove the accent and then turn that letter into a standard one. So, you'll find this in like older APIs, especially that are ASCII coded and they only, accept ASCII characters. And if you're dealing with one that's sort of hit or miss, sometimes APIs have shitty documentation or that sort of BS. Just pass it through an ASCII function just to be sure. So yeah, that's sort of like data cleansing, if you want to call it that. Okay, now we get to one of my favorite functions of all time, the replace function. The replace function has tons of utility. It's extremely versatile and you can do so much with it. So I'm going to spend a little bit of extra time on here. But essentially this replace function, if you've ever used find and replace in Google Sheets or something like that, you're probably pretty familiar with this. But it's just a way that you can take a string, and then depending on whether that string has some other thing, you can replace that with your own string of your own choosing. So if I wanted to replace, I don't know. Here's a great example. A lot of the time we have like domain names, and then I don't know, we want to isolate certain parts of the domain. So let's say we know every single time the domain name is going to be Google, but then there's some query and maybe there's some name at the end of it like Katerina. A really quick and easy hack is just to replace the Google part. And then you can just replace that with an empty string. And I mean, if you run this, you're only going to get the Q equals Katerina. You can also, let's say we only wanted to like get the Katerina part, we could just replace the whole question mark query. And then, the end of it is like we receive some URL parameter, and maybe that's some URL parameter we're going to use in another part of our flow. So, a lot of utility there, a lot of things that we can do. Man, it's a sunny day today. So yeah, replace is very, very valuable in that case. You can also do obviously simpler things. One of the primary use cases that I personally use for replace is, I use a lot of proposal generation software. Like the thing that I'm most interested in with make.com is always like developing very simple, but like very high ROI, like customer experiences, like where somebody on my team will do 5 seconds of work and it'll deliver an experience that the customer thinks took them like 10 hours, right? I love that sort of thing. That's what gets me really excited. That's what gets me up in the morning. So, one of the things that I do all the time is I'm always like involved in some proposal generation or some asset generation or, contract generation or whatever. And unfortunately, something that happens very often with proposal platforms is they don't allow you to send new lines in text. And what this means is you might write something or generate something or have a template, and then you'll pump it into an API like Pandadoc or Quillo or something like that. And then, on the back end, it'll just strip all of the new lines, and then it'll just give you this huge like wall of text, which is really ugly and nobody really wants, right? So we can actually fix that using replace. Let's say I feed in a text, and it's like, "Hi, Peter, I hope you're doing well. I'd like to talk about XYZ," right? And we feed this text as it is into an API. Well, a lot of the time the API is just going to strip all those new lines. What we can do in order to fix this, actually, let me see if make.com itself strips these new lines. No, make.com keeps the new lines. But anyway, what we can do in order to fix this is we can use the text and binary function. We can use a special keyword here, and we can replace all new lines with like an actual hard-coded new line character. And most APIs will take this hard-coded new line character and then use it as a way to reconstruct spaces or new lines in the string. And so what I've done here is I've pasted in this text. Then we're going and replacing all the new lines. And so if you think about it, like there is a new line character sort of in between these two, the comma here and then the I on the next line. So it's taking that, it's cutting it, and then it's replacing it with this \n. It's doing the same one over here. And then the end result, if I run this again, is now I have it in a format that these APIs like, where it's all just sort of in one line, and then the new lines are just replaced with this \n character. And then because this is just like a universally agreed upon new line standard, on the back end, their API will reconstruct the new line sort of structure. So very, very nice. I use replace all the time, probably one of my top 5 functions. So that's replace. Let's talk a little bit about trim. Now, if you guys have seen my previous videos, you'll know that I very routinely will like scrape websites, and then I have a bunch of like unformatted text. Specifically if I'm doing, I don't know, something where I take a piece of, I don't know, I'm attempting to isolate or scrape like a URL or maybe like a person's name or whatever. A lot of the time I'll end up with a bunch of white space to either side. So that might be like, I don't know, like a bunch of spaces here, and then a name, and then a bunch of other spaces over here. And what you can do is, if you just pass this through the trim function, it'll just automatically remove all the white space before and after. And so the way to use this, and the reason why you might want to use this, is just if the formatting is inconsistent. Sometimes there's no white space, sometimes there's like one white space, maybe 10% of the time. Passing a string through the trim function will just sort of cover your ass and make sure that you're okay. So I use that pretty often as well. Okay, sweet. We're now on to upper. Upper is basically like the opposite of lower, which is, I mean, pretty appropriately named. I think make.com did a good job here. If we pass in something that's lowercase mostly, and then we pass it into the upper function, it will convert every single character into its uppercase form. So that's hopefully pretty straightforward. We also have substring. Substring's super cool. I don't really use it as often as I would probably like, especially these days, because I've just replaced all of my usage of substring with replace. But you can do some pretty cool things with substring. Let's say you're, I don't know, finding a list of URLs or something, and then you're attempting to isolate the domain name because you want to feed that domain name into some other service and maybe generate domain name variants for like a parasite SEO campaign. You can do that really easily with the substring function. Let's say I'm just attempting to isolate the google.com part. Well, what substring basically allows you to do is you feed in a string, and then you can slice it based off of like the number of characters in the string. It's easiest for me to show you with an example, but basically if I'm attempting to isolate this part, the google.com part, and I know that all the every time a URL comes in, it has this HTTPS thing, and it's kind of ugly, and maybe I don't want it. I can just like strip that out and then only get the google.com part. And the way that I do it is I go 1, 2, 3, 4, 5, 6, 7, 8. I go 8 characters deep. And then I go all the way to the end of the string. And the way to do that is you just calculate the length of, the thing that you're feeding in. So we're using a length function to get the length of https:// google.com. That'll be the end of our substring. And then we are just counting the number of characters at the beginning. And this is just allowing us to isolate the domain name that we're interested in, which is google.com, hypothetically. So you can use substring pretty creatively to do stuff like that. You can also use it to isolate like query parameters, like I was mentioning earlier. And a lot of the time you'll be using this in practice when dealing with links and sort of processing things and URLs and that sort of deal. So substring could be very valuable. Okay, there's also index of, and you can use index of in conjunction with substring to do some pretty cool shit. But I had an example earlier, and actually just to make this even simpler, why don't I divide this into 2 parts? We'll define something called URL, and this will be, maybe let's make this a little more relevant. Your API goes here. You're a pig O's. Okay, that doesn't really. Let's just go yourapi.com, and then you have like a bunch of query parameters. And this is the URL that we're sort of feeding in here. And then in the playground, what we want to do is we want to get the index of, if we, I need to save this unfortunately and then access this again. Okay, so we want to get the index of this URL, and then we want to find the question mark q equals. So we want to get like or I guess what we could do is we could go, we could do like .com question mark equals whatever. But basically we want to get the index of that question mark. So we want to see how many characters into that string does it occur. So it occurs 19 characters in. And then maybe we want to grab the substring of index of, so this is going to equal 19 characters in for that specific string. And then I'm going to jump ahead a little bit here and just show you like a math function. We'll do a plus, and then we'll do, I think, question q, I think that's 3. And then we're going to go all the way to like the length of the URL. I think that's 12.url. And then we run this. We can accomplish, I don't think that worked. Let me just make sure that this index of URL question mark query parameter is working correctly. So that equals 22. Now we're getting the substring of URL from 22 and then onwards. Let me run this puppy. We're getting it from the beginning right now up to 22, so that's not really what we want to do. Let's do length of URL now. This may not work. Oh yeah, there we go, it did work. Let's make this a 2. No, let's make this a 3. Okay, great. Pretty convoluted example, but I think you guys get my point. If we run this now, then we receive only the query parameters that we're interested in. And then what we can do with this, using another function, which I can show you in a second, is we can separate them based off of the presence of this A. Or what we could do is instead of 3, we could just cut right to the Q. We could run this. Now we have question, whatever question mark Q equals. Actually, let's do +1 here. Run this one more time. We'll get Q equals XYZ and A equals BCD. And now we could just split this based off of the presence of an ampersand. And now we have, basically an array with various parameters. And, if you wanted, you could further split the substrings to eliminate the Q equals and the A equals. This would basically help you isolate a bunch of URL parameters, which you could then use in a later part of the flow, or maybe use to recall an API or something like that. So hopefully that wasn't too convoluted. We're going to get into a couple of functions here that I really don't use very often. But I told you that I would cover every function, so I'm going to talk about them. The first is toBinary. Binary is just basically like a one-to-one representation or a mapping of characters in numbers. And so the reason why I show this is because I just put the letter A in there, lowercase a, and then it evaluated to 61. If I put the letter B in there, it'll evaluate to 62. If I put the letter C in there, it'll evaluate to 63. I think, if I put the letter Z, it'll be like 97 or 98 or something. Oh, I guess it's 7A, that's because it's in hexadecimal. Anyway, you're basically never ever going to use binary. There are some like fringe cases in which you'll be evaluating, I think, like data that's coming in and then there's some APIs that will request data in binary, and so you can just feed in whatever you want, then send it in binary. But you can just think of this as like it's like translating from one alphabet to another, right? A is equal to 61, B is equal to 62, C is equal to 63, whatever. All you're doing is you're feeding it your string, and then it's translating it one for one into this big binary representation, and then you can send it to an API which maybe like only accepts binary. So in practice, I've probably used the toBinary function like one time in the last year, so it's probably not something that you're going to use very often. I wouldn't really worry too much about it. Okay, let's keep going. Right before we do, looks like my face is pretty white, so let me just, well, my face is pretty white. That is correct. My face is very white. Let's make this a little bit lower. Okay, I think I fixed it. Great, so let's keep going. Let's do the toString function. ToString is pretty interesting. I mean, I wouldn't worry too much about type conversions and stuff like that, but to keep things simple and to explain it in a way that everybody understands, there are a bunch of different like variable types. There's like a string, which is obviously just a collection of characters. There's like a number, and I think it's called num or maybe number in make.com, but that's usually just like 1, 2, 3, 4. And if something's a string, it's kind of hard for you to like use the plus operator between two strings. Like what is, hello plus how are you equal, right? Like mathematically, can you really perform mathematical operations on strings like that? Turns out you can, but it's a little more complicated. You can do 1 plus 2. That's pretty straightforward, right? The reason why we have these different types is to make it very simple to like define things that we can and can't do with numbers and strings. So like you can do 1 plus 2, but you can't do like A plus E, for instance, right? Make.com is actually pretty liberal with this, and so they actually let you get away with way more than you'd be able to in like any programming language, which is good because the purpose of Make.com is to like help you make a bunch of freaking money, not to, you know, nerd out over academic theory of strings and ints and floats and all that shit. But you know, toString is basically just a way that if you get a number, let's say you get like 17 point whatever, and then maybe you want to use this as, maybe you want to like use this in like a proposal or something, or like there's no real mathematical function or purpose to have this 17.349348. You want to use this in like another value that maybe formats it better or something like that, then you just convert it to a string. Or there are going to be some instances in which you have special operators, stuff like, I don't know, null or whatnot, that you are sending, and maybe you want to like convert them to a string for whatever reason. You can use the toString operator to turn the null from this like special variable into like an actual, oh, I don't think I can actually do that. That's unfortunate. Maybe true is a better example of that. You can convert like this Boolean operator, this true, from, you know, like a Boolean item into like a string instead, and then maybe you could do, I don't know, like upper or something to it if you wanted to convert this for some API that hypothetically we want to take capital letters. And if you're working with an API that would only take capital letters, you should stop your subscription immediately. Fuck them. Okay, so that's toString, encode URL and decode URL. You know, I very rarely use these, but essentially, you know how in URLs there are, like if I were to put a space here and then I were to go like ASDF, I were to paste this somewhere else. You know, if you pay close attention, you'll see that, you know, that space that I added between here has now been converted into this like %20. The reason for that is because URLs, like there's sort of a universal standard where URLs do not accept like spaces and they do not accept certain characters, because this would make it, I think, like insecure when you are accessing a resource on the web or whatever, because some of these characters like reserve characters that you use in like programming and stuff like that. So you don't really want to allow anybody to like do programming stuff here, right? Like drop tables or whatnot. It's a programming sort of joke and I'm very lame, so I'm not going to do that again. But you know, encoding a URL basically just allows you to get a bunch of text that you want to put into a URL format, like edit a whatever, and then it'll replace all of the characters that are not really accessible or allowable in URLs with these ampersand numbers. So %20 is a space. I think %26 is like an ampersand. You know, there are a bunch of different characters essentially that you can encode in URL. And so what you're probably noticing is like a big function of all of these string functions, or one of the main use cases of a lot of these string functions, is converting from like one encoding format or one language or one alphabet to another. And you know, that's a lot about what programming on the web nowadays honestly is. You just have an API that only accepts one format or one language, and then you're using another API which outputs things in another one. And your job is just to connect the two. You know, it's just to convert things from one format into another. Make.com is the glue that allows you to do that. So decode URL is pretty simple. Same sort of idea. You know, if I have like a big function like hello, how are you? And then I pump that in, it'll just take that and then replace it with the spaces or the characters that, you know, people are more used to seeing in strings. And so you might use this pretty often if you are doing some type of like scraping where you are identifying a bunch of URLs on a page. And, you know, sometimes you'll see all sorts of characters and they're all encoded and they have like hashtags between them and they have like number sign 20s. What you can do is you can pull that and then, you know, like feed that into some type of artificial intelligence thing to maybe recreate or maybe rephrase a slug. And then you could use that as like the slug of a blog post or whatnot. Lots of stuff you could do with encoding and decoding URLs, although in practice, to be honest, I don't really use it that often. Okay, so on that note, where we're doing encoding or changing from one language to another, something that I think everybody that wants to make a large amount of money with Make.com in the future should get in the habit of learning is a little bit of basic HTML. But you know, if you're unfamiliar with it, HTML is just like another language where you can basically enclose elements within these right or left greater than symbols. So maybe like B. And then the presence or absence of these modifies how the text is rendered on the browser. So for instance, like, you know, lower B greater hello, and then lower \B greater. This basically just bolds the word hello for you. You know, if I bolded the hell and then left the O out, it would render as like a bolded HELL and then like a non-bolded O. And so, a lot of the time, this is a very special language, and because it's like universal, hypertext markup language is used on the web. Like this is how all of these web elements are being marked up, basically. If we go onto the back end of these, if we view the page source, you'll see it's just all HTML. Well, maybe not all HTML. This is mostly JavaScript, so bad example. But if you look closely, you just have a bunch of HTML here that's sort of like marked up and whatnot. Because this is so universal, there are many instances in which like APIs or services do not want to allow you to use HTML in them because it's a security risk or because of some other formatting reason. And so this function, escape HTML, just lets you basically remove HTML and then replace it with like something that is equivalent, that is also understood to be regeneratable. So I just fed in this like, hell O right here, and then what it did is it replaced the less than symbols with and LT, that stands for less than, and then a semicolon, which I think just means character over, and then there's a B, and then there's an and greater than semicolon, that just means that character is over as well. Then we wrote hell, then it was less than, backslash B, and greater than O. I think the O stands for, oh, actually no, the O is just in my string, never mind. So yeah, you're probably not gonna use that super often, but I figured I might as well cover it. Now you will probably use, oh, sorry, there's one more called escape markdown. Markdown is just sort of like an alternative HTML, you can think of it as, where instead of doing these, left and right greater than symbols, you are instead using hashtags. And so, in HTML, there's an H1 and an H2 and an H3, and these are like headings. And, in the past, they corresponded to the size of the heading. So like H1 would be like your biggest heading. H2 might be like a subheading. H3 might be like a subheading, right? Well, Markdown allows you to do the equivalent thing in fewer characters just by using a hashtag. So maybe instead of that H1 thing, we just replace it with this number sign and then a space, and then it says header. You'll know if you've watched my videos on AI that anytime I'm prompting AI and trying to get it to like output some article or some content, I will always prompt it in Markdown, and I'll say use Markdown ATX format, because that way I can like preserve a bunch of information related to headings and subheadings and that sort of thing. And so, if for whatever reason the API or the service that you're connecting with does not accept Markdown, then you can escape the Markdown and it'll just replace it again with its own sort of character set. And then you can regenerate that on the back end. Okay, great. That stuff's super annoying, so let's get to the cool shit. Strip HTML. I think I showed everybody here, or all of my longtime watchers, in a previous video, how easy it is to scrape a website with Make. All you do is you go to the HTML or HTTP request module, and then you put in the URL of your site. So in my case, I'm doing leftclick.ai, right? If I just run this puppy, and then I click and then check out the data, you'll see that I just scraped the entire website. I have all of the HTML of the website. All it took was like a couple of buttons. This is everything that is present on my website, just in HTML format. But HTML is really long. And a lot of the time I'm feeding content like this into AI, and I don't really want to spend a fuck ton in tokens. I mean, how much does this cost? This is 62,420, right? Instead, what you can do is you can take the output of that, and then you can escape the HTML. So I'm just going to add one more set variable here, and then I'm going to feed in this stripped HTML. I'm going to run, and we'll show you the difference between before and after. Before, the HTML coming out of the HTTP make a request module is huge and it's massive, and there's some words here that I think we understand, right? Process optimization, but it's wrapped in all these tags. But if I look at this strip HTML output, then you'll see that there's no HTML here at all. All it is just pure text. And this is now so much shorter. This is something that you can easily feed into AI, save yourself a ton of money while doing it, and then maybe have it tell you something about the website. So I use strip HTML quite often. There's also a designated module called HTML to text, and you can use this module. It does the exact same thing as strip HTML. I think maybe it has some slight differences in how it evaluates line breaks or some shit like that, but really not that big of a deal. But this is a whole nother module, so you're basically consuming an additional op to run this. And if this is something you're doing hundreds or thousands of times a day, obviously you want to minimize the consumption of these ops wherever possible. You want to run more profitable flows. Try and use the strip HTML module instead. Okay, great. So that's that. Let's keep moving on. What other functions do we have to work with? Contains. Contains is something I use all the time. If you have an array, let me create an array here. We're going to talk about this in a second, but a very quick and easy way to make an array is just to like split a string based off the presence of a comma or some delimiter or character. And so what I'm doing here is I'm creating an array with 3 elements, John, George, and Paul, and then I'm just splitting. I'm splitting based off the presence of this comma. It's sort of a hack, but anyway, if I were to run this module, I fed it in as a string, and the output is I get like a little array data type. That's why it says array in the sort of light gray text there. And then I can like access indexed elements of this array. I'll cover that in a sec, but essentially, so what I'm doing is I'm going to feed in this array, and then I'm just going to check to see whether this array contains George. If I run this, you'll see that the output is a Boolean. It's a true or a false. And so now that it's a true or false, now I can do a bunch of cool shit with it. I'm going to cover if statements later, but the if statement, I can feed in like if true, then do something else. And by feeding in contains like this, and then using contains as opposed to like, I don't know, like a filter, I could feed in like every item in here. I could iterate through this whole thing and then like filter it one by one. I'm saving a boatload of operations. And so this is sort of like a smarter way to do checks to see if an element is visible, and then use that as some other part of your flow. So I use contains all the time. You're probably going to use it as well. I think I just showed you how the split function works, but essentially you feed in a string, then you feed in some delimiter, and then you can divide that string into an array with however many elements are delimited. Delimiter is just a separator. So in this case, I'm going to use this vertical line as a separator, and I've put it sort of my format. The split is you add the string, and then you add the separator, and then you close it out. And then this will turn into an array with 2 elements, one the first and the other the second. You can split by whatever you want, by the way. If I split by the letter A, I have the letter A in there a bunch of times, so we're probably going to see a fuck ton of these. Yeah, there you go. It's quite useful. I mean, I use it as sort of a hack just to generate arrays quickly, but the utility of it goes far beyond that. Let's say I'm feeding in a URL. Well, a very quick and easy way to split this URL into 2 parts, maybe that domain that I was trying to isolate earlier, is just by splitting it into 2 elements using the presence of those 2 backslashes. And now I have HTTPS and then google.com. And there's a function, which I'll show you in a moment, called get, which allows you to feed in an array and then get the first, second, third, or nth element of that array. So if I know that the google.com part, the domain that I'm interested in, is always going to be on the second half, I can just feed in 2, and then the result is always going to be just exactly what I want, the domain name. So this is a design pattern that you will see me use all the time, and it's just like the quickest way to consistently isolate an element of an array or a URL or something like that, based off the presence of a delimiter. Okay, that about covers the most important parts of string. Next up, there are a bunch of what I consider unimportant functions. I probably never use these even once in like a real function for a client or for my own businesses, but I'll cover it just for brevity, just for completeness' sake. The MD5 function is basically like an encryption scheme. You know how earlier I showed you the 2 binary function, and then A was equal to 61, B was equal to 62, C was equal to 63, and so on? MD5 is basically, it's a similar idea. It's just a way to like encrypt a string. Like let's say this is my password, and if you feed this string into this MD5 function and run it, the result will be this long non-human interpretable thing. But you can regenerate the original string easily by applying like the inverse MD5 function. And I don't know if they have like an inverse MD5, but let me see. MD5 to string online. Let's see if they have this. Let's say I stumble upon this thing in the web, and then I decrypt this. The result is this is my password. So essentially, you can think of this as like another alphabet that I'm converting all of my letters into. It's a little bit more complicated than that because you're performing some mathematical functions that relate, I think, to the length of the array and all that, or length of the string and all that shit. But yeah, just a very simple and easy way to think of it. And you're probably never going to use this. And if you find yourself using make.com for like cryptographic encryption, decryption stuff, you're probably not using make.com the right way. Make.com should be extremely simple. A lot of the time it's like strings, arrays, and dates. And you're usually like modifying some external data source that like other team members have access to, not passwords. There are also variants of the MD5. So, the same idea applies for SHA-1, SHA-256, SHA-512. These are just increasingly complicated ways of encrypting and decrypting data. So MD5 is like the simplest. SHA-20 or 512 might be the most complicated. And if you run this through SHA-512, for instance, you'll see the string is a lot longer. And mathematically, it's a lot more secure, essentially, if you want to like encrypt and decrypt. There's also base 64, which is just another conversion method, just like to binary, where instead of converting it to binary, you're converting it to what's called base 64. You know, a lot of people may or may not be confused by stuff like this, but I'll be honest, you really don't need to know this sort of shit in order to make it very far with make.com. I didn't know any of this stuff. I was not necessarily a very proficient computer programmer when I started this. I watched a bunch of like online YouTube tutorials, and I knew what HTML was. I knew what markdown was, but I wasn't good at using them. I never really built anything of value. But even though I lacked that knowledge, I was still able to go very far with this. So if what I'm saying doesn't really make sense to you, or if you're thinking, oh man, when the hell am I going to use this? Don't worry too much about it. Just keep on trucking along, and you'll probably find value in other sections. Okay, great. That is string, text, and binary functions. Next up, I want to run you guys through the second most important feature of make.com, which is the mathematical functions. So let's get into it. Now, mathematical functions are pretty interesting because I think there are a couple of hand-me-downs from like programming or Integromat, or it's kind of more like nerdy academic features of make.com, which most people don't really use in practice, but I'll walk you through them regardless. The first is there's this pi variable. Now, I think most people here probably know what pi means. Pi is just like the mathematical relationship between the radius of a circle and I think it's circumference or something like that. Yeah, I think it's radius to circumference. If it's not, then sorry, area to radius. Jesus, man, it's been a while since I've hit up math. Anyway, 3.14159, whatever. It's this long string, a long number. You're probably never going to use this in practice unless you're working specifically with like some math package or math library. I have certainly never used this before. And if you find yourself, again, doing math in make.com more than just like simple addition or summation or averages or something, you're probably using it wrong. So anywho, you can do some cool shit with it, but yeah, probably not for monetary purposes. The next variable here is random, and this is probably like my most commonly used math thing ever. Random allows you to generate numbers between 0 and 1, I believe inclusive. And you're probably like, well, 0 and 1, like that's sort of annoying. Why the hell do I care about 0 and 1? Can't I like just set a minimum and a maximum, have it generate a random number that way? Yeah, I think ideally you would, but you can do it really simply by just multiplying this random number by some number. So in my case, 5. So now instead of generating 0 to 1, I'm generating 0 to 5. You're also probably thinking, well, like, why does this matter? 3.358. When am I ever going to need to like generate a number with 16 decimal points and have that be relevant? Well, you don't really need to. The math library includes a very convenient function called round, when now you can just like generate an integer randomly. So now it's generating 4. Now it's generating 1, right? And now you're probably thinking, well, when the hell is that useful? Man, let me tell you. One of the most common features in project management is like randomized assignment, or like randomized load distribution to different members on the team. And you can accomplish this really quickly. If I go back to my previous array generators string and I add 2 more names, let's add a couple of female names in there. Okay, so John, Erica, Paul, Nick, Sarah. So if I then generate, actually, let me just run this and show you guys. So if I have like a team roster with 5 people, John, Erica, Paul, Nick, and Sarah, and then I want to randomly assign work to one of them, what I can do is and I'm jumping ahead a little bit, I'm using the get function here, but I can feed in an array, and then I can feed in the index of the person that I want to select from that array. And if I randomize that index, then basically every time I run this, I'm going to be generating a randomly assigned person. So now I'm picking Paul. This next time I'm picking Paul again. Paul's pretty lucky. Okay, fuck, maybe there's something wrong with my thing. Okay, yeah, there's probably something wrong here. Let me see. Get playground. No, that should work. My God, did we seriously just generate Paul 4 times? Wow, that's just the likelihood of that is very low. I think that's like 0.2 raised to the 3. Yeah, man, that's like 0.8%. Anyway, the way that this works is it's basically just not round robin, it's just randomly picking people's names. And then I think I needed to add another person here, which is probably why it's not working on that run. But anywho, the point that I'm making is you can use this very simply to randomize things that you might need some element of randomness to, like selecting a person on the team to assign a certain task to or whatever. Now, obviously, there are different ways to do this sort of random assignment. You can also do round robin assignment, which is just when you go one after the other, after the other, after the other. But this is just one that I use quite often. I'll also use this to generate content a lot of the time. So like a lot of the time, when you're generating content, you want to vary the formatting of the content and stuff like that. So, if you're using templates, you might want to randomly select templates, that template 15% of the time, that template 30% of the time, that template 40% of the time, to provide the illusion of your content being random. Maybe on some you have like 2 paragraphs, then an image. On others you have like 3 bullet points and then like an exclamation or a table. On the next section you might have like a bunch of images, and then you might have like some quotes. You can randomly select the likelihood that every one of those are going to pop up by using this random function, and then using that in conjunction with get, and then feeding the output of that to some other thing. So I do all of those quite often, and yeah, I mean, random and round are probably like my 2 most commonly used math functions as a result of that. Okay, let's walk through a couple of these other ones. Average is pretty straightforward. You basically just calculate the numerical average of a few numbers. You can feed these in one at a time, so I've fed in 3 and 8. The average of this, unless I'm silly, should be like 5.5, yeah. Or you can also feed in an array. So you could theoretically, if you had some big number array, you could feed it in here and then just calculate the average of that. This is similar to a bunch of other functions. Let me skip ahead here. Like sum. Sum does the same thing. So you just add up 3 and 8. There's no real point to use sum when you could just use addition. I think that addition, the addition operator here is just a lot more straightforward. So I'd encourage you guys to stick with that. Max just helps you identify the highest number in an array. So max of 3, 8, and 10 obviously is 10. The min of 3, 8, and 10, if we replace this, would be 3. You can feed in arrays to basically all of these mathematical functions will be the same. I'm just using individual numbers here to be simple and quick. And then, yeah, I believe that's it for, yeah, those. So let's cover ceil and floor now. Just like round, sorry, lets you take, let's say we have like 1.9. Just like round allows you to feed in 1.9 and then as an output get 2. Ceil and floor allow you to pull a number up or down to a whole quite easily. But there's some nuance here, and I think it can be pretty difficult for some people to understand if they don't sort of have that like intuitive programmer sort of brain at this point anyway. Basically, ceil will return the smallest whole number, well, integer, I should say, but the smallest integer that is greater than or equal to a number. And if we just parse this in language and just show you a bunch of examples, like if I have 1.9, the smallest whole number greater than 1.9 is going to be 2, right? It's not going to be 3 because 3 is not the smallest whole number. The next one up is 2. It's also not going to be like 1 or anything because I'm looking for a number that's greater than this. But likewise, if I were to feed in 1.0001, this number would still evaluate, I should say, to 2. Because 2 is the smallest whole number greater than 1.0001. It doesn't matter how close we are to the floor, this function is ceil, so it's grabbing like the next number up, essentially. So if you think of it, I wish I had my tablet here, but I'm in Prague and I'm a little limited in terms of stuff. But if you think about this like a number line, where they're like little notches on this board, and it's 0, 1, 2, 3. Basically, anywhere you are on the number line, if you do the ceil function, you'll just go to like the next big notch. Next big notch, right? Floor does the opposite. So the floor of 1.00001 is going to be 1, right? The floor of 1.9999999 is also going to be 1. Because on that number line, if I'm all the way over to the right and really close to 2, it doesn't matter, right? The nearest notch on the left side is 1, so it's going to pull you back. So that's how those work. And I don't really use ceil and floor very often. I usually just use round. But some people use ceil and floor all the time. I think I used floor in my content generator. Aside from that, I really don't use it. Okay, great. Now we have 2 very useful functions, which I wanted to cover in conjunction. There's parse number, and then there's format number. And I use these all the time. One of my big use cases is, I deal with money. So I'm sending out proposal requests, I'm sending out contracts, I'm sending out like Stripe invoices, whatever. And I want to be able to format money. What do I mean by that? Well, let's say I have a number, and that number is this long-ass number. I'm charging a lot of money here. This number isn't very pretty, right? Well, maybe I'll make this a little simpler. That way it's not going to be. Let's say I'm charging, I don't know, $120,000 for something. If I were to, in my beautifully worded proposal, just stick this number in with no formatting, I think it would look kind of stupid. And so what this allows you to do is this allows you to essentially, I feel like I'm about to sneeze. This allows you to essentially apply some formatting to a number based off like pretty common conventions. Now I'm in Europe right now, so the convention is like a dot and then the thousands, but you can change the hundreds and the thousands separator pretty easily by putting a semicolon and then putting the number of decimal points you want your resulting number to have, which I want 0, and then to put a decimal separator, which in my case is a period, and then a thousand separator, which in my case is a comma. And if I run this now, what I'm going to get is I'm going to get 120,000 with like that nice, beautiful comma in the middle, which is a lot more human interpretable and human readable. And let's say I wanted to turn that into like a dollar figure. I just add a dollar sign ahead of it, and then I'd run this module. So I've converted like 120,000, just a number that maybe I resulted from like a mathematical calculation or whatever, into a nicely formatted string with like the thousand separator put in the right place. So I use format number all the time. And it just really makes numbers interpretable. If I run this with a bunch of extra zeros, notice how it's now converted that to 1.2 billion. And it's just, you instantly know because you can see the 3 commas. The inverse of this is parse number. A lot of the time, if you are scraping or something like that, there'll be numbers. And the numbers will be like, or whatever, right? Maybe there's a dollar sign there too or something. And maybe you want to do something to it. You want to like multiply the number by 2, or maybe add some, I don't know, you're doing some project management, and part of your project management flow involves getting a PDF with like the request for proposal, and then taking the budget and then multiplying it by 1.5 to like give yourself some internal room. Well, you can feed in that number, and then you can format, like, if I look here, I fed in $1, like this terribly formatted number, which makes no sense. And then the output of this was I got this nicely formatted number. And then what you can do is you can now run mathematical operations on this. So I can now do a multiply by 2, or maybe 1.5 or something like that. And then I can run it. And now I can get the other number. And then what I do is, let's just make this a little less dumb. Okay, great. So this is my 1.5 billion or whatever multiplied by 1.5, right? So I'm going to run this. Input was 1.5 billion. The output is 2.3 billion. And now what I can do is I can feed this into a format number module, add a dollar sign, add 0 decimal points, and then add my separators, and then run it again. And I've basically taken in a number, or a string, I've turned it into a number, then performed some mathematical operations on it, then I've reconverted it into a string, and then maybe I can send that back or use it in like some other function. So these are very, very important. And that's that for math functions. We are now going to move on to the third most commonly used function category, which are our date and time functions. I use date and time functions, all the date and time. Essentially, there are 2 different ways to represent dates in programming and in make.com more specifically. The first is a timestamp. Timestamp is just like, well, let me run it and show you. Timestamp is the number of seconds from January the 1st, 1970. Which, if this is the first time that you've done anything like this, you're probably like, why the hell are we picking the number of seconds from January 1st, 1970? The reason why is because basically just a bunch of computer guys got together and just agreed, hey, we do need like a standardized way to count from some date in order to like make all our computers work. Let's just pick January the 1st, 1970, okay? Everybody shook hands, and this is the format that we now use, called Unix timestamps. And essentially, the reason why we use this is because it just makes it really easy to back calculate dates and shit like that. I mean, number of seconds, if you just multiply or divide seconds by 60, now you have number of minutes. And if you divide that by 60, you have number of hours. Divide that by 24, you have days. Divide that by 365.25, I think, you have number of years, right? So it's just very easy from a mathematical perspective just to hardwire this in, and then use this as sort of a frame of reference. And so, there are 2 sort of ways to represent it. The first is that timestamp, and then the second is a very long sort of agreed upon date time format, which make just refers to as date. But essentially what it's doing is it's taking the timestamp and then it's just applying a bunch of functions to it to render like a date and time in human readable format, like March 29th, 2024 at 4:42 a.m. So pretty cool that way. Like in my experience, I most commonly use the date and time format in Make through using the now function. But there are always going to be some APIs that are sort of pesky and sort of annoying that are going to request that you use timestamps. So just good to understand what both are. And like, I didn't even know this until maybe like 3 months ago, and I'd made tons of money with Make up until that point in time. So isn't super critical. Just make sure that you at least understand the difference between the 2. So why does this matter? Well, if you have a function that can easily take a timestamp or evaluate the current date, and then if that date is an easily understood format that any API sort of gets intuitively, you can just pass this now and it'll just automatically know you're referring to like today. You don't have to do any conversions, you don't have to do anything. You can do a lot of cool shit with it. Like if I want to add, I don't know, let's say I want to set a due date. I have a task coming into my project manager CRM, and I just want to set a standard due date of 1 week. Well, underneath here, you see the functions. There are tons of add seconds, add minutes, add hours, add days, add months, add years. And essentially what I can do is I can use the add days function to take today's date and then just add 7 days to it. And then if I run this, I now have April the 5th, 2024 at 4:44 a.m. What I can do then is I can use this in my API call or in my integration. Maybe I'm creating a new project in ClickUp, then I can automatically set the due date exactly to 7 days after the task is created or the task arrives. This allows so much freedom and flexibility in the way that you set due dates. You can store like a big project tracker with the deliverable and then the amount of time it takes, and then you can just pull from that and then use that to replace, the add days day variable. So a lot of freedom that you have there. All of these other features work the exact same as add days. Add seconds, add minutes, add hours, add days, add months, years. So I'm not gonna beat that horse to death, but I hope it's pretty self-explanatory, like the value of being able to do this. Getting some current date, modifying it based off of like, it's just a preset library of functions that work on like a known data type. And because the vast majority of APIs accept this data type, you can go really, really far with this. Okay, so that's now, and that's the add feature. What if you wanted to set the day, set the date, set month, set year? A common feature request when I'm working with people is, especially agencies, is they have set billing dates. They'll have like April the 15th, April the 30th, April the 28th, whatever. Like they have some type of date and time where their invoices go out or when a subscription needs to be made. So let's hypothetically say we get a new client today, and then we need to set the next invoice date at April the 15th, right? Today's March 29th, April the 15th is what, like 17 days away? I can't just say now and then add days and then do 17. Because what if tomorrow a new request comes in? Well, now it'll be April the 16th that we're setting the invoice date to, right? Sort of silly. That's what the set function suite does for you. If instead I wanted to set the date to, well, actually, let me just show you how this works. Let me first evaluate the now. If we just evaluate now on its own, it's March 29th, right? If we set the date of now and we say 15, what it's going to do is it's going to keep every other feature the same, every other element of my date. So the month will be the same, the year will be the same, even the time will be the same, but the date will be different. So now we've set this to March the 15th. We fed in March 29th. As a result, we've gotten March 15th. And so what I can do is I can now use this in conjunction with my add months feature, and then I can add 1 month to March the 15th, and then I can get April the 15th. And so in this way, I can consistently always get the next month's payment period, whether it's 45 days away, 32 days away, 17 days away, it doesn't matter. It's just always going to be, the exact like next billing period that the client or maybe me wants. You can also do this for your own payroll, right? If you're trying to like sum up a list of time entries or something like that to calculate your own payroll, you can set like the 15th to the 30th. You can back calculate that, and then you can like set or queue up a payment to be made on April the 15th exactly, as opposed to other dates or whatnot. And this sort of thing saves tons of time. CFOs in particular love this sort of thing because they spend anywhere from like 5 to 10 hours per week just queuing up payments. And you can just do all that automatically and then just set them up so that the only thing a person needs to do is once every 2 weeks, just look over all the payments, give them a thumbs up, and then go from there. Pretty neat. There are a couple of other functions down here like format date and parse date, which I use quite often. Basically, remember how I said there was this format where it's like in human readable format, and if I just use the now function, then I run it, it'll be like this nicely beautified March 29, 2024 at 4:48 a.m. Well, if I go back to this date picker and I mouse over format date, what you'll see is in red, there's like the actual machine interpretation of that. And that's 2016, or I mean, in my case, it'd be different, but here it says 2016-12-28T. Then there's the hour, then colon, then the minute, then the colon, then the seconds. And it looks like there's even like the milliseconds as well. So that's sort of like the machine format that make.com will pick up and then parse for you automatically. But what that basically means is if we feed in now, which renders to that red thing, sort of like behind the scenes or under the hood, and then we want to convert it into some other date-time format. So maybe instead of it being rendered as like March, whatever, we want it just to be, I'm in Prague now, so maybe some like weird European format. We want it to be like month, day, year. We can feed that in, and then we can convert a date object into a string. And so we just fed in that like long March 29th thing, which I think looks a lot sexier, but we've converted it into this date-time format, month, date, year. And this is really useful because you would not believe the number of APIs that only accept dates formatted in very particular ways. Alternatively, you can be scraping data sources or PDFs or assets or something like that, maybe emails, and then there's just some auto-generated thing in a specific format, which means something different to you because you're in a different part of the world or whatever. And what you can do is you can take that and you can parse it using the parse date module, which is the exact opposite of the format date module, where maybe I have some date and that's like 29/03/2024. And then I feed in some date and time tokens here. So this would be date / month / year. And basically it's just reading this date and then it's saying, okay, what is this 29? Oh, this is the date. Okay, what is the 03? Oh, that's the month. Okay, what is the y? Oh, that's the year. If you run that, it'll then convert that back into like your beautiful date format object, which you can now do things like add days, 3 to. Run this puppy again. Now we have April the 1st, and then maybe if you wanted to, you can then format the date back into this god-awful format. If you just like hate life and enjoy murdering babies or something. So yeah, that's the date and time function. Super useful, I use them all the time. Last but not least, there's this sort of calendar picker, which allows you to set specific dates. So if you wanted to feed in like March the 5th for whatever reason, you could do that, and you could also change the time and that sort of thing. In practice, I rarely ever use that. The most commonly used date functions are format date, parse date, and then adding a couple things. And I'll almost always use now instead of a timestamp, as I mentioned, because the vast majority of services only accept, or the vast majority of services prefer now, and there are a couple of fringe cases where they want the timestamp. Okay, and that takes me to arrays. Now, arrays are super useful data types to understand. What I'm going to do over the course of the next few minutes is just walk you through sort of like the rationality behind arrays and how they differ from objects in make.com. Essentially, an array in make is sort of like this. It's like you have item 1, item 2, and item 3. And I'm putting these square brackets here because that's how most programming languages like represent an array. But basically, if you feed this into like a parse JSON module, I think we need to wrap this with, I don't actually know if this is going to work, but let's just do array and do this. If you feed this into a parse JSON module, then the output is going to be our nicely formatted like indexed item 1, indexed item 2, indexed item 3, and then in future variables you can like access the sub elements of that array. Like you can do 1, 2, 3, 4, that sort of thing. So arrays are used primarily to iterate through things in make, which is quite useful, as I'm sure you can imagine. And that's what all of these array functions do. They take something that is formatted in this way, where you have like a bundle, and then you have an array, and then there are multiple items in the array, and then they just do something to it. So what I'm going to do here is I'm going to use this parse JSON module as the input for our array functions, and then I'm just going to walk you through a bunch of different things that you can do with it. So the first function is join. Join is the sister to split. Essentially, where split turned a string into an array, join turns an array into a string. And so instead of splitting based off some delimiter, you can join based off some delimiter. Now I said item 1, item 2, item 3 or something like that, but when I run it through the join function, the output is going to be a string that's item 1, comma, item 2, comma, item 3. I use join reasonably often, but not super commonly. Length is basically the exact same thing as the string version of length. It just allows you to get the length of an array as opposed to the length of a string. So if we feed in this array, even though the string version of that might have like 20 characters, the array version of that only has 3 characters. And so it'll sort of pick up whatever data type you're feeding it in. If it's a string, then it'll calculate the length in characters. If it's an array, it'll calculate the length in items. Next up, we have keys. Now, keys is pretty interesting. In order to understand this, you need to know what like an object is. So let me cover really quickly what an object is in make.com. Objects are interchangeable with collections. And if you guys look at this, and then we zoom way in, when I outputted my parse JSON module, it said bundle 1, and then it said collection. The reason why it's a collection is because I have this like comma array, and then I have a colon. So an object is basically something that follows this format. I'm just going to open up a new module here, and let me just auto-align these because it's starting to look ugly. Let's just call this object. An object is just something that has a bunch of key value pairs. So this would be key 1, and this would be value 1. And then if I run this, the output is going to be an object with a key and then a value. And you see it's sort of like nested, whereas arrays are just like item, 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 or value, 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 value. Objects just allow you to define a key and then a value. And you can obviously you can swap and switch and add multiple data types together. So you could have like an array of objects. You could have an object that contains an array, for instance. But anyway, the reason why I show this is because there's a function called keys that allows you to evaluate just the keys of the object. We can extract just whatever the keys are. So I have to run this all together in order to get access to the variable here. But you see how we're going to feed in object, and then I'm just going to put a right bracket there. If we run this now, basically what I've done is I've turned my object into an array, and that array contains one item, and that's just the name of the key. Okay, we got a couple of other functions here. There's slice. Slice is pretty straightforward. You basically feed in an array, and then you can index elements of that array. This is the spiritual sister to substring for the string functions. So if I had an array, which I think, let me see, good God, I'm consuming tons of ops. Whatever, I'm doing it for the gram, man. If I feed in this array, which is item 1, item 2, item 3, I can slice it, and then only, I can basically cut it at 2 and then only show number 3, if that makes sense. So that's what I've done here. I've sliced it at the number 2, and I'm only showing number 3. Make.com, like string indexing, array indexing is kind of weird and kind of annoying. Sometimes you do 0 indexing, which is where you start an array by counting the first element as the 0th element, and then the second element is the first element. And then some other functions start at 1, 2, 3, kind of like normally, intuitively. Unfortunately, there's just no really quick and easy way to understand this. Maybe if there's enough demand, I can tabulate a list of functions that are 0 indexed and 1 indexed, but just run it once before they start using it in an actual flow, and it should be okay. So anyway, I've cut this 3-element array at the 2 mark, and then it's only showed the 3rd element. If I cut it at the 1 mark, it'll show the 2nd and the 3rd element. So now I have item 2 and item number 3. And yeah, you'll use slice from time to time, but I don't really use it that often. I'd much prefer the ability to just pick and choose the elements that I want, which I cannot wait to talk about, the get function. Oh man, I use the get function all the time. But anywho, that slice. Merge allows you to combine 2 arrays. You can also just feed in the same array multiple times if you want to make duplicates, so I'll do that here. You basically just separate them by semicolons. So I've fed in the same array twice here, and the end result is I'll have an array with 6 items, item 1, 2, 3, item 1, 2, 3. I don't really use merge that often. To be honest, you don't really need most of these array functions, but anyway. Contains is, again, the spiritual sister to the contains function in the string library, where you basically just feed in a big array of values. So I'm going to go back here and feed in my array, and then I'm going to say, hey, does this contain item 2? If it contains the value of item 2, then I want you to return a true. If instead, we're looking for item 555, it's going to return false. And we can use this in logical flows later on, which makes it very, very valuable. There are a couple of other ones here. There's remove. So you could remove a specific thing from an array. So if I'm feeding in my array and then I want to remove the item 2, then I'm only going to have item 3 and item 1. I will never use remove. I just don't really see a purpose to continuously perform operations on the array. I'd much rather just grab the elements that I want, but perhaps there are some cases in which you may. And then there's also add. The only situation in which I ever use add is basically you can grab an array and then you can just add an element to it. So the only situation in which I'll ever realistically use an array, add. First I'll show you how it works. So add array item 4. So I'm going to add a 4th item basically to this array, and obviously it starts at the end when you add a new item. But the only real situation in which I'll use this is I'll use the empty array keyword, and then I'll just use it to create a quick array. So it's sort of my split hack where I split a string into its constituents based off some delimiter. I'll use the empty array and then I'll just add items. So I can create my own 3 item array by just saying add empty array item 1, item 2, item 3. And if I just run this, the end result is the same thing as my little split hack. So one thing that I want to make very clear is you can do the same thing 20 different ways in make.com and in programming more generally, and in life even more generally. But with make.com, my best or my number 1 recommendation is just find the way that works for you, and then just learn that really good inside and out, and then just use that over and over and over and over again. The perfect programming practices or whatever, they don't really apply here since we're concerned about making money, and we just want to be able to wireframe something as quickly as possible. A lot of the time that just involves, using flows that you understand and know. The next function is probably my most commonly used array function, and maybe one of my most commonly used functions in general after get, split, switch, and then another one that I'll cover soon. But the map function allows you to feed in a big array and then basically filter based off the presence of something, or then only extract certain elements. Probably the best way for me to show you this is if I go back to this big parse JSON thing where I have array item 1, item 2, item 3. Actually, let's see this one. Okay, you see I have object key 1, value 1. So let's hypothetically say that I'm running some type of social app where I have profiles, right? So my object is now called profiles. The name is Nick. There'll also be the hair color. And the hair color is, you guessed it, brown. I'm a blondie at heart. And then let's say I have a couple different entries. One is Sam, her hair color is blonde. One is Petra, and her hair color is black. So I have my JSON object here, and if I run this, assuming it's formatted correctly, the output is an object with a key of profiles and then a value, which is an array, and inside of that array are 3 items, one with name Nick, hair color brown, another with name Sam, hair color blonde, and last with name Petra, hair color black. So bear with me here, hopefully that makes sense. Now that we're well established in our example, let me just isolate this specific subflow and then delete the rest of this. Now that we have our example, what I'm going to do is I'm going to feed in profiles. And I'm just going to run through a couple of things. Let's say I don't really care about the hair color or whatever. Or no, let's say I don't care about the names. I just want to get a list of all of the different hair colors that are available to me. Well, in order to do that, all you do is you feed in the top level array, so in my case profiles, and then you feed in the name of the attribute or the key that you're interested in. So I'm interested in hair colors only. If I run this, I will basically remove all of the other information in the object and then convert it into an array which just enumerates over all of the various hair colors that I have. So this is very useful if you just want to get a sense of all of the different options that maybe an object or an array contains. More importantly, there are ways to filter using map to select only elements that you're interested in. So for instance, if I wanted only to select hair color, okay, let's say instead of hair colors, I only wanted to return names, right? So if I run this right now, I'm going to receive Nick, Sam, and Petra. But let's say I only wanted to receive or output names whose hair color is equal to brown. Well, now I'm only getting Nick. And so you can use map to basically save you 99% of operational costs. When I say operational, I mean like the operation side of things, by feeding in the arrays that you'd otherwise feed into like a filter, and then just using map to like do all of the filtering up front in like one shot. It's a super quick and easy hack, one that I use all the time, and that's why map is one of my most commonly used functions. I'd highly recommend, if that little brief demo that I showed you didn't make any sense, actually read through the map documentation. It's not bad. I think in order to understand it, you just need to understand that, like, you know, when you see something like a variable called hair color, like that's underneath the name of it, it says raw, and then it says hair color. That's like its actual variable name, and you can use that variable name in this function and many others in order to like access that key. So pretty handy, highly recommend. We have a bunch of like sorting ones, which I will almost never use. There's shuffle. Shuffle, basically, if you feed in an array of item 1, item 2, item 3, it'll just randomize the order. So it'll be item 3, item 2, item 1, or item 1, item 3, item 2. Sort just allows you to sort based off of usually alphabetical order or date and time. You have a bunch of variables here that you can add. So, you know, if you wanted to sort our array of profiles, let's say, and you wanted to do it by name, you could do so alphabetically. And the output of that would be an array where the name starts alphabetically with N, P, and then S, because N is before P and P is before S in the in the dictionary. So yeah, you can sort things in practice. What this usually looks like is sorting based off dates. If you're making an API call and a bunch of information is coming in, and I don't know, it's just not like well formatted or something like that, or not formatted, but the information isn't sorted by dates, you can usually just use make.com to sort for you. But you know, the vast majority of the time, APIs will do the sorting much better than you could. So I would just go with the data from the API. I got a fantastic little cup of orange juice here. One of the things I love about Prague is just how fresh all of the juices and stuff are. I think they probably have some like top-down EU regulation. But man, that tastes good. Okay, now we're going to talk a little bit about reverse. Reverse is just where you'll feed in an array, and then you'll convert that array, or we're not going to convert it, you're just going to like basically flip it so that instead of item 1, item 2, item 3, it's item 3, item 2, item 1. Again, there are very few use cases in which you'll use this. You can also use the sort function with the parameter descending or ascending to basically reverse however something is sorted. So reverse doesn't really serve a functional purpose. First and last are just ways that you can quickly get the first item in an array or the last element. So you know how earlier I split, HTTPS, google.com, and then I split it based off the presence of this. If we ran this, then we'd get an array with 2 elements. Let's put this in the middle here. An array with 2 elements. One is HTTPS, one's Google. Well, you can also just use the last function to select like the last thing in that array, which is Google. So just the same way doing, what we did previously with the get. Now I much prefer get, but I'll talk about that in a sec. Okay, and then we have flatten and then distinct, deduplicate, to collection, to array. So flatten, it's kind of weird, but there are going to be some instances where you have an array, and then inside of that array, you're going to have like another array. So let me just show you guys what this might look like in practice. If we render our JSON and we check the profiles, what you'll see is there are 3 items, and then there's a sub-array containing item 1, item 2. So basically we have an array within an array. This is sort of annoying, and a lot of APIs will unfortunately do this. But a quick and easy hack to basically turn that into just like a 1-level array, basically to flatten the array, is to feed it through this flatten function. And so if we feed in our wonderful profiles array here, and then flatten it, and we run it, then what we're going to do is we're going to pull out those items, and then instead of it being an array nested within an array, everything is going to be on the high level now, on the top level. Now this is tangentially useful. This is more of a programming thing, but you will find that some APIs, for whatever reason, nest things like 30 different subarrays deep, and flattening is just a way to bring it all up to the top level and then maybe feed it through map. So like a design pattern that people will normally do is you'll have like some array, some nested array here. You'll flatten the nested array, and then you'll map it to pull out, I don't know, keys that only have a certain value or something. That's how that works. Distinct is just a way, distinct and deduplicate, like in practice, are very similar. There's a minor nuance between them, but just treat them as the same for the purposes of this video. Deduplicate just helps you remove duplicates. So if you had an array, so let's do empty array. Oh, sorry, I can't actually do that. I need to use this keyword. If we create an array with item 1, item 2, item 3. And just to walk you through what's happening here, I'm defining an empty array, then I'm adding item 1, item 2, item 3 to it, and then I'm deduplicating it. What we're going to do is we're going to remove any items with the same value. And so there were 2 item 1s, now there's only 1 item 1. And distinct does virtually the same thing. It just allows you a little bit more latitude if you are if you're using like an array of objects instead of an array of values. But it simply allows you to filter based off of whether a name field is the same or a hair color field is the same or that sort of thing. So that's pretty cool. And then we get to 2 functions which I have literally never used in my whole life, which there are actually a fair number of make.com videos out there on the internet about, which I find hilarious because they're so divorced from actual functional effectiveness. To collection and to array. You're basically virtually never going to use this, but to collection converts an array into a collection. To array converts a collection into array. So remember earlier how we defined an empty array, and then we said add, and then we did like item 1, item 2, item 3. Now we have an array with 3 items, item 1, item 2, item 3. What you can do is you can use this function called toCollection, and then you can basically convert this into, sorry, it's what's the term? Okay, actually, let me just run this and see what happens. Okay, yeah, this doesn't work because we don't have key value pairs. Let me try item 1. Let me try running this. Yeah, no, it's still empty. I guess what I'm trying to say is this is so functional, like these 2 functions are so useless, for lack of a better word, that you will virtually never ever actually use them in practice. If you have an array that contains objects, and so if we have, actually this is probably a good example. If we have an array that contains objects, which we have here. So if we run this is profiles, and then the type is array. And it contains 3 objects, which again, make.com also calls collections. Remember there's that like semantic disambiguous or ambiguity there. But essentially, we have an array with 3 objects or 3 collections: name Nick, hair color brown; name Sam, hair color blonde. We can convert this whole thing into just like a top-level collection with names, and then I don't really know what the value would be here in this case. Not really sure. But let's just try putting both of these here and then running. Okay, so what we've done now is we've, instead of, remember earlier how we flattened something and then we pulled the keys and the values out? Basically before we had an array of profiles, and nested inside of, we had an object, and then inside of that object was an array of profiles, and then inside of every profile was, it's like an object with name Nick, hair color brown. What we can do is we can redefine that object using the toCollection, where instead of having like the name Nick, hair color brown, we've now just pulled out the key and we made that the name. And then we can make the value something else. So I tried making the value hair color. I don't really think that works. Maybe I do this. Then I run it. Yeah, okay, cool. What we've done now is we've redefined this object, and we basically turned it from this sort of nested structure into just this collection with 3 keys, Nick, Sam, and Petra, and then the corresponding values we pulled out of our array using this like indexing scheme. As you could tell, I virtually never use this, and you're probably never going to use this as well. I'm just covering this for due diligence purposes, but I think that, to be completely honest, this is something that, yeah, like you're probably never even going to look at, and if you never look at it, you're still going to be fully capable of making a ton of money. There's the inverse, which is toArray, which is basically where you convert a collection into an array of key value collections. Just because of how silly this thing is, I'm not going to beat it to death, but if you have, let's just redo this. So you have profile name, let's just say it's like a value called Nick, right? If we run this, oops, did not want to add that module. If we run this puppy, we now have like an object with 1 key profile name and 1 value Nick. If we feed that into this array, and then we run it, empty is not a valid collection. That's weird. Oh, sorry. Should have done profile name. Oh, sorry. Actually, this isn't going to work either. I need to do 1 level up. We'll do object, and then we'll do profile name Nick. There we go. Yeah, as you can see, I do not really ever use these functions, and that's why I'm quite poor at them. Anyway, what we've basically done is we've taken our object, which is just profile name Nick, and then we've converted it into an array, and the array has a sub-object which now has a key of profile name and then a value of Nick, and then actually uses this key value pair like syntax, which again is sort of silly. You're never going to use it. Anywho, hopefully you did the smart thing and you skipped the last 5 minutes of explanations on those two, and we can move on. All right, that takes us to general functions, which are pretty simple, I think, intuitively to understand, but it's more of like just covering all of our bases here. You've probably already used a lot of these functions. I think you already intuitively understand probably what like if statements and else statements are like, but we're going to cover them regardless. And I need to make sure to plug in my battery before I like blow up my computer or something. So just give me a second to take care of that. Okay, now that we're not going to blow up, let's run through some general functions. Now the first is you have an execution ID. That just refers to the ID of this specific execution. If I run this now, you'll see that it generated 93BF. If I run this again, you'll see that it generated 5E8A4B. If we go back to the history, you'll see that there is a details page for each of these. And then if we click on both of them, you'll see that the URLs contain the IDs that we just generated. So the URL of the first run, 93BF9, and the URL of the second run, 5E8A4. This is just a way that you can very quickly and easily isolate a specific execution. In practice, how this works is when you are developing flows that a lot of other people on your team use, and you want to maintain them and make sure that they never really muck up. What you do is you basically grab the, like let's say I'm updating a CRM or something like that. What I'll do is I'll also add a comment at the end of that with a link to the specific execution. I think it's logs. I think that's it. But anyway, in my case, this is my US1 make.com account because I'm on the US server. This is the ID of my account. This is the ID of my specific scenario. This is the logs page, and then this goes to the execution ID. So, I'll usually like wrap this in some type of tag, and then I'll say like execution ID. And then if it outputs HTML, it reads HTML, I now have like a button that anybody on the team can quickly click to get to that specific execution, which can be quite valuable. There are obviously some very simple mathematical operators here, like these are brackets, and so you can use brackets to group expressions together, like 5 plus 2 times 3, let me do this correctly, times 3, that equals something different than 5 plus 2 times 3, right? And brackets just allow you to isolate various mathematical expressions mostly. You're mostly using that with the math library, so don't worry too much about it. I'll cover gets now. Remember how earlier I split a string? And the example that I did was based off of a URL, and I was attempting to basically just isolate the domain. Well, if I split based off the presence of these 2 backslashes, the end result of that is I'm going to have an array with 2 items, one with HTTPS and another with google.com. Get is just a very quick and easy way of selecting which item in an array you want. So if I selected item 2 and then I ran this puppy, it equals google.com. If I select item number 1, it's going to equal HTTPS. And just to show you guys what's going on under the hood, using split, right? When I do this, I get my array, and then I just use get to select the element that I'm interested in. Now remember, there's also the first and the last function, so I can split this, and then I can just grab, well, I guess in my case I'd be interested in the last, and this will do the same thing. But if you think about it, like, wouldn't you rather use a function that allows you to quickly change whatever element you want and not just be restricted to the first or the last? I definitely would. Some people will call this less maintainable or less readable, but c'est la vie. I much prefer just like the get feature for everything. So I'll usually use get in probably like every scenario. It's just that ubiquitous and useful. There are a couple of additional functions here, which you'll understand if you come from a computer programming background, and if not, I won't walk you through them too heavily, but there's if. And an if statement is basically like, if true, then return the first element. If false, then return the second element. And so the examples here are pretty simple. It's if 1 is equal to 1, which is a true statement, right? That's obviously going to evaluate to true. Then return A. Otherwise, if it's false, return B. And then the example evaluation here is A, because 1 equals 1 is true. Now 1 equals to 2 is false, right? So if we were to do the same thing but pass this as the expression, then we're obviously going to return B. So this is one of the instances in which I think like the make.com documentation is actually great. If 1 is equal to 1, maybe return like Peter, and then, if not, return like Wick or something, I don't know. 1 equals 1 is true, so we're going to return Peter. Now, in practice, you're not really going to be doing logical operators like this. Instead, you're going to be using another function called ifEmpty. Usually what you're doing is you are like calling an API, and then you're seeing whether an element exists. And if the element exists, then you're going to do something. And if the element doesn't exist, you're going to do something else. And so you can do that with just the if statement, but the ifEmpty is just like an optimized version of that. Let's say I'm setting a variable. Let me delete this, then use the set variable, remove this, and then I'll just call this some like API variable. And we'll just, let's just do first name. And so what we're doing is we are basically calling an API for the first name variable, and then it's returning the value Nick. What we can do is, if I close this and reconnect this, because I just added a new variable, what we can do is, if we go to our general functions and then write ifEmpty, we can make a design pattern where basically we could say, if first name is empty, then I want you to output something else. So maybe, we have like a placeholder name or something for a proposal or whatnot. We're calling an API to like get a name, and then we use the name to populate our proposal. If first name is empty, then add placeholder. And if it's not empty, then we just want to do whatever first name is. So if I run this in practice, because I've added a variable here called Nick, and I've actually added the value, the output is going to be Nick. But let's just say it's empty for whatever reason. I get nothing. If I run this now, then the output is going to be placeholder. Essentially what this means is it's just like a one line and very easy and interpretable flow where I can just define, hey, in the off chance that this is empty, I want you to do something else. So quite useful in that way. Next up, we have probably my other most commonly used function, which is called switch. Switch is basically the exact same thing as an if statement. It's just multiplying the if statement a bunch of times for different outcomes. I want you to think of this as like a giant input to output map. If the input is one thing, then I want you to output another thing. If the input is this thing, then I want you to output that thing. If the input is this other thing, I want you to output this other thing, right? If the input is A, I want you to output 1. If the input is B, I want you to output 2. It's just a very simple map that you can build to simplify your life. And another reason why I really like this is it eliminates the use of routers. Routers in make.com are really annoying. Let's say you want to generate like a proposal, but you, I don't know, have like 10 different proposals that you can generate depending on whether it's like service 1, service 2, service 3, whatever. In make.com, what most people do is they will add a router to your flow, and then they will add like 10 different routes. They'll say, if first name, or let's say service name is equal to, I don't know, like website or something, then we'll do one flow. And then if service is equal to, oops, that's ugly, I don't know, like SEO or something, then it'll be some other flow. And we'll say website and then SEO. Now, the reason why I hate routers, and routers just suck and you should try and get away from them whenever possible, is because if you think about it, you just duplicated your work. We have 2 routes here, but imagine if we had 10. Now we've multiplied our work by 10. Let's say in the future you want to go through your route and then you want to make an edit to one tiny little thing. Well, now you need to make that same edit to this route, the other routes, that route, and so on and so on and so forth. And so what switches allow you to do, our switches are basically just routers, just included in a variable instead of, on sort of like a module level, if that makes sense. So what I'm doing here is, let's say I have a service name instead of first name, and my service name is called website. And then because I just added a new variable, I have to reselect this. And basically, if an input is website, I want it to output some, I don't know, maybe some email or something like that, some long proposal. Hello, well, maybe an email. Hello, we can't wait to help you with your, okay, sorry, I actually fucked up there. If the input is website, then the output would be, hello, we can't wait to help you with your website, or something. And then if the input is SEO, then we'd say, thanks for submitting an SEO request. We're excited to help you build a great SEO campaign. Let's just hypothetically say. Okay, and let me run you through the syntax here. Basically, the way that it works is, what you do in a switch is just like an if statement, you have some expression. And if that expression evaluates to value 1, then you output result 1. If the expression evaluates to value 2, then you'll output result 2. It's basically a series of value result pairs, basically. And then the very first element you do is just always your input. So in my case, I've said switch my input depending on whether it's equal to website or it's equal to SEO. If it's website, I want you to output, hello, we can't wait to help you with your website. And if it's SEO, we want you to output, thanks for submitting an SEO request. So if I run this, my input was website. So my output should be, hello, we can't wait to help you with your website, right? But if this was SEO now, and I ran it, the output is now, thanks for submitting an SEO request. We're excited to help you build a great SEO campaign. And so we basically accomplish the same thing that you'd accomplish with a router. We've just done it in a single variable, and we've done it a lot faster, honestly. So highly recommend you guys use switches wherever possible. Now, if you guys add a final semicolon, you can basically create like an else route, and then you can say, I'm not going to write the, screw you, I don't want anything to do with you. And what this means is, this is basically like if nothing else matches. So if, I don't know, we want social media or something, then the else route will be evaluated. So this is just a good way to like catch every single possible input and then treat it in some way. So yeah, very, very powerful stuff. I'd encourage you guys, if you want to get the highest ROI out of this, go through the map documentation and then go through the switch documentation as well. Use it in your flows and just really understand it, because those are probably like the biggest operation savers and the biggest maintainability savers as well. Okay, and then there are 2 other functions, one called omit and the other called pick. These are silly. There's no real reason to use them. They're just like sort of hand-me-downs from Integromat, which is the predecessor to make.com before they got all purple. Pick is just get, just written in a different way. And it's where you can get things based off of their keys. But, like You can also get things based off their keys, so I don't really see the point of it. Anyway, if you have an object and the object has like key value pairs, like key 1, value 1, key 2, value 2, what you can do is you can pick only the keys that have the name that you are interested in. So if I go back to this parse JSON, and then I make my own object again, and then I have key 1, and then I have value 1, and then I also have key 2, and then value 2. Actually, wait a second. I don't need to do that. What am I talking about? I'm all over the place here, and I don't need that either. Okay, so if I create this object, what I get is I get an object with 2 keys, key 1, value, key 2. And then if I feed this into my playground, and then I say, hey, I want you to pick from this object, which is 23.object, I want you to pick only key 1. Well, the output is going to be an object with only the key 1, value 1 pair. Likewise, if I want you to omit key 1, now the output is only going to be key 2, value 2 pair. So you'll basically never use this, and I wouldn't really worry about understanding it too much, but it's worth at least covering. There are a bunch of logical operators here, which I think are self-explanatory. Equals is how you get like, A equals B, then do C, right? That's how you get the evaluation or expression part of the if statement. There is a bunch of other ones. There's unequal to, there's like greater than, less than, over here on the math function side of things. But I think most of these are self-explanatory. The ones that you might not understand are and or, and you'll just never use and or. But essentially and is just a way. So if the variable on the left of and the variable on the right of and are both true, so if they are expressions that evaluate to true, then this will output true. But if one of them are different, so if this is false, let's say, then the AND operator will evaluate to false. This is sort of a hand-me-down from programming, and I think it's just make.com trying to cover its bases and be academic and all that stuff. Or is the same as AND, it's just it evaluates to true if either of the two are true. So it's like A or B, right? Versus A and B, where both need to be the same. And you can use these in if statements, but I don't really think that. I think that you can do everything that you would be able to do with and or with equals if you just convert things to numbers, or if empties, because in reality most of the time you're just calling an API looking for something. Okay, that's that on the general function side of things. The last thing that I want to cover are the custom and system variables, and I'll do this a very light touch because, to be completely honest, you're very, very rarely going to use these. I should note as well that not everybody will have access to the custom and system variables. I have access to it, I think, because I'm on a specific plan. You may not have access to it if you're on like the starter plan or whatever the simplest one is, but anywho, they can be pretty useful. But really the only variable that you're actually going to use here are operations consumed, operations left, because those are the ones that are important. Essentially, remember earlier how I had an execution ID, and then I tried to I like put down some URL, and then I wrapped it in like an href equals to like make a link. Well, you can do that really simply by going down to scenario URL and then just going /execution ID. I think scenario URL /logs maybe /execution ID, and that's just the same thing. And that way, instead of having to hard code a scenario URL, you can just do it dynamically. So you can copy and paste this or export it as a blueprint, and it'll just work elsewhere. Custom and system variables are basically like meta variables. They don't do anything for you specifically for this thing. They're just like meta organizational or scenario information. You can get data consumed, which just tells you the bandwidth. Execution started at, the start time, the stop time. If like the start time is a little longer or something like that, you can, I don't know, use that in some flow to like auto detect or tell you that there's an issue. If there's a problem, it's an incomplete execution, you can also add that to some queue. So you could theoretically have like a watcher, and then if it's an incomplete execution, if this is equal to true, then you could have an additional thing somewhere where you like log that and say, hey, this is an incomplete execution, you should check in on it. There's some team variables, team ID, team name. You're never really going to use this in practice. And then some organization variables, and really the only valuable one here is operations left. This will show you the number of ops left at the end of every scenario run. And the really cool part about this is you can trigger another workflow with this. Like you could say, if operations left is less than 500 or something, then send Slack message to somebody. So you'll use Slack module, and then you will check to see if this passes the filter. And then if it does, then maybe you send a Slack message to the ops guy on your team being like, hey man, your operations are running low. Just double check and this is what you want. Click this button if you want to buy more. The reason, by the way, why I buy more ops instead of like set up auto buy or something like that, is because make.com does a really weird thing where, for whatever reason, they charge you more when you enable auto purchase than they do when you buy things manually. I guess they're charging you for the ease of use or some shit, but I think it's kind of like a dark, deceptive practice. I'd much rather they get away from it. Regardless, this is just a way that I like keep my pride intact, and I'm like, I'm not going to pay more for, automating the purchase of my ops. And I usually just buy a really big plan, and then I'll like send a request or something like that if I get really low instead. Saves us, 20, 30% or more. So yeah, that's that. Okay, guys, thanks so much for watching this video. If you have any questions on specific functions, if you're still here, first of all, congratulations. But if you have any questions on specific functions, or maybe you want me to like record a whole video on just like the map or the get, feel free to drop it down below. The documentation in make.com can be pretty sparse and can be pretty confusing, especially due to the ambiguity and how they define objects, collections, arrays, that sort of thing. So, I've tried to take all of that unnecessarily verbose academic language and convert that into something that, just casual viewers will understand. But if I failed in that in any way, shape, or form, just let me know, and maybe I can re-record a specific part. Otherwise, I really appreciate you guys making it this far. To longtime viewers, you'll notice that I'm probably in a different place. My background is quite off. And I haven't recorded a video in for absolutely forever. That's because I've moved to Prague to work with a company whose founder and team I respect very much. I'm now sort of like their full-time operations guy, and it's going extremely well. We're doing a very exciting turnaround time. So part of that was because of the YouTube videos that I'm posting consistently, as well as some of the partnership contracts that I've been pushing to my clients. And it was just such a good opportunity, I couldn't say no. So I'm here in Prague, really enjoying my time, and yeah, I'm looking forward to, now that I have like a reasonable setup and everything, recording some more videos consistently. Anywho, like, comment, subscribe, do all that fun YouTube stuff. I'll catch you later. Thanks so much.